Well, welcome, Delaro Physics students. Yes, this is Delaro Physics, but there's some things you're supposed to already know from previous courses. And so this is not a chemistry course. Please don't freak out. But there is one chemistry idea or not idea, I suppose. In fact, it's barely even a chemistry idea, but the ability to handle units. So we learned in chemistry there's lots of different kinds of things you can measure. You can measure length. Units of length could be meters, they could be feet, they could be miles. We also learned that you could measure mass. Mass is given the letter m in equations. Notice that when it's in an equation, it stands for m. When it's after a number, it stands for meters. So 3 meters, that m is meters. But if I said m times a equals f, that m is mass. So in the mass units that we're going to use is supposed to be the kilogram. Now in chemistry we use the gram, but the SI, or Système International unit, is supposed to be the kilogram. You can measure time, you can measure volumes. There's lots of kinds of things you can measure. Now it is important that you remember from chemistry that if I have something that is in one system of units, for example 3.0 miles. Now I have the 0.0 to say there's 2 sig figs, but I can tell you that in physics we're not going to worry too much about sig figs, so don't worry about that right now. I can't help it because I'm a chemist in my heart. If I want to know how many meters that is, we learned a technique called dimensional analysis where we can say 1 mile is 5,280 feet, and that would give me how many feet is a mile. Now if I want to know how many meters that is, we would continue on and say 1 foot is 12 inches, and 1 inch is 2.54 centimeters, and 100 centimeters is 1 meter. Okay, so we did that last year, and we would calculate that out, and we would have a length in meters that is the equivalent length to 3.0 miles. So that's a skill that we learned last year that I'm hoping you still remember how to do. You'll have a conversion sheet just like in chemistry. You will not have to memorize any of these conversion factors. We do have to use the conversion factors on the sheet. For example, 2.54 centimeters is an inch because that's exactly 1 inch, 2.54 centimeters. And so we're not adding any additional error by saying that a mile is about, whatever it is in kilometers. So we're going to continue to use accurate or exact conversion factors. We also learned last year that if you had something like this, 3.0 gallons, and I wanted to convert that to hours. Well, we learned, or you're supposed to have learned, to first recognize that gallons is a volume, and see if that focuses, and hours is a time. Okay. So how do you do that? Well, you can't convert a volume to a time unless you're given a ratio that has volume and time in it. So if you knew that something, a pump, let's say, moved 2.00, liters per minute. Well, that is a ratio that compares a time to a volume. So I could use that in the middle somewhere. And this is what it would look like. 3.0 gallons. Now gallons is a volume, but it doesn't look like little cubes. So it's supposed to be volumes are supposed to be cubic somethings. Fortunately, we know a gallon is a nickname for 231 1-inch cubes. There, now I have a volume unit. If I converted that, that would be the number of cubic inches, that is 3.0 gallons. Now, to use this ratio, I need to change cubic inches to liters so that I can then change it to minutes and then change to hours. So what's a liter? Well, it's very similar to a milliliter, which is the definition of a cubic centimeter. So I'm going to say 1 inch is 2.54 centimeters. I'm going to write that 3 times though. So I put a cube on the outside. That way these cubic inches will cancel those, and I have cubic centimeters. Then I can say a cubic centimeter is the same thing as a milliliter, and 1,000 milliliters is a liter, and I can say 2.00 liters is a minute. And I can do one final conversion that I wrote too big for and say, let's see, minutes is in the top, so 60 minutes is 1 hour. And I would have the number of hours it would take a pump moving at 2 liters per minute. That's the number of hours to remove or move 3 gallons. This has 2 sig figs, this has 3, so my answer would have 2. All the intermediate values are exact, so I don't have to worry about those for sig figs. And this is just a reminder of how we tried to get you to really think about units and what kind of unit you're talking about in chemistry. So we have a gallon, you're supposed to say, oh, that's a volume, and hours is a time. We had other things we did with units. For example, we had a very simple formula that said if you want something to accelerate, you push on it. Well, that's F stands for force. If something has a large mass, the acceleration will be small. If the mass is small, the acceleration will be big for a given force. So we had units. The unit we're supposed to use for mass is kilograms, and we learned that acceleration is meters per second, or meters per second squared. And this combination of units has a nickname called a Newton. And so we had lots of things we did with units where you had to remember, well, a Newton is really a kilogram meter per second squared. Now we'll review that again slowly as we go through this semester. But we had other combination or derived units that we came across. The Newton was a force or a weight. We had pascals, which was a pressure unit because it was a Newton per square meter. That's a force per area. We had work or energy, which was a joule, a Newton times a meter. And we'll review these as we go through. But just wanted to have you sort of remind your brain, that's that part of your brain that still has some chemistry knowledge in it. Tonight's homework is just a couple of conversion problems, and hopefully they're not too bad.
Yeah.
And here's your homework.